Yeah. So this is your example problem. So the solution is already given in your textbook. So the why I'm explaining the same question is just to make you feel comfortable with the directions. Okay. So if you look at this problem, he mentioned that an object is placed 4 centimeters in size. That means he is giving, okay, let's take that object as candle here. So what he is trying to explain is the height of this is 4 centimeters and it is placed at a distance 25 centimeters from a concave mirror. So this is our concave mirror and at what distance it is placed? 25. So this is 25. Here u is 25 centimeters. Of focal length 15 centimeters. So this is focal length 15 centimeters. At what distance an image is formed? We know first we can write the formula. So I don't know whether the place is sufficient or not. So first I'll make it into half. 1 by f equal to 1 by u plus 1 by v. We know this formula. So it's all about not placing the numbers. It's all about if this question is given for 2 marks or 4 marks, he's not testing your mathematics skills on this one. We know f is f value is focal length is 15 centimeters. Good. And u is placed at 25 centimeters. Good. And he is asking v. It is easy, right? We know f, we know u, we can find v. All depends on the convention. That is the tricky part. Let's handle the tricky part. F equal to 15 centimeters. Well, is it positive or negative? Okay, let's see. So, what our sign convention always says? Measure distances from pole. So, focal length. Focal point is here. I have to measure from the pole. I think I'll pretend like I'm here and I have to measure from the pole. I will walk like this slowly to measure the focal length. I'll walk in this direction. So what our sign convention says? If the direction of the light is positive, I am going opposite. So direction of light is like this. I am moving in the opposite direction of it. That means it is negative. Because I have to measure it from the pole. Initially I have to stand here and walk towards the focal point. So definitely I am walking in the opposite direction of the light. So it is negative. So, and let's take the what to say, distance of the object from pole, that is u. Is it positive or negative? Let's see. So I have to start from here because I have to measure all the distances from pole. I am stressing this point, from pole. So you have to be there and walk towards the object. How you walk? You walk in the same direction until you reach the object. So you are walking in this direction. The direction of light is in this direction. So these two are opposite. So you take a negative. Okay. So now we got the negatives or positives. Now let's put the values. So I'm just replacing and moving the numbers here and there, and 5 2s, 5 3s. So 1 by v is minus 2 by 75. V equal to minus 75 by 2. So all are in centimeters. So this is centimeters, equal to minus 37.5 centimeters. So that's the value. So again we got negative number, minus 37.5 centimeters. How we have to pretend? So what it means is 37.5, all the distances what you have to do, measure it from the pole. So you are here. Now we have to count up to minus 37.5, right? So that means you have to keep walking. And this is the what? 25 centimeters, right? Until this point, we have to walk up to 37.5. We have to keep walking, keep walking. Why I have to walk in this direction? Why can't I walk in this direction? Because it is negative. I have to go opposite to the direction of light. Direction of his light is this one. This is positive. To make it negative, I have to walk in the opposite direction of the direction of light. So I have to walk in this direction. So I have to walk. At 25 centimeters, I made this one. But still it is 37.5. I have to keep walking. So I have to walk until 37.5. Think this one. Here the image is formed. So why I took this image? Initially I can take any distance. But finally the result will come. Image is formed here. That's the objective of this one. Sign notation. So once you understand the sign notation, you can do anything. So that's all about the sign notations. So you know, so height, why he gave the height 4 centimeters. We didn't use this height anywhere. So I wrote the half of the problem. Another half of the problem is magnification. So I will explain what is the how much magnified the image is. Okay. Yeah. So one thing if you observe, so the way image forms, that is way, right? It doesn't depend on the height of the object. So height is 4 centimeters or 40 centimeters. So the image formation doesn't change. So it only depends on the focal length and also where the object is placed. It doesn't depend on how tall the object is. So you need to remember that one. Then why he gave the 4 centimeters? Just to, but this height, image height depends on the height of the object. If the height is bigger, it might be bigger or smaller or something. So that time height is important. Only for calculating the magnification related things. So that's all about, that's where we need the height of the object. So how we measure magnification? Magnification equal to height of image divided by height of object. Okay. So, and it is always, we put negative because image is formed. So we already learned going up is positive, heights. So this is positive. Image is formed downwards. That's why we take it negative. Okay. Yeah. So I know that okay, the images are formed negative, but if we remove this one, so this is actually the formula for the magnification. Height of image divided by height of the object. So how it will be? So from the formulas, like, okay, they say like hi is the height of the image and ho is the height of the object. So hi by ho is equal to minus v by u. This is the formula, and we derived this one already. So if we do this one, height of the image, or to say, we need to determine height of the image and height of the object. It is 4, ho equal to 4. Always leave the gap in front of 4 to put a sign. We are going from the principal axis upwards, so it is positive. So hi by 4 equal to v. How much we derived? So we already got it in the previous one. It is minus 30, this one. And u, what is the u value? It is 25 centimeters. How it was? We are going in the opposite direction of the light, so it is negative. So if we replace all these things in this formula, minus of minus 37.5 centimeters by u is minus 25 centimeters, and this is 4 centimeters. Cancel, hi equal to minus of minus is positive, 37.4, sorry, 5 multiplied by 4 and minus 25 centimeters. So which is equivalent to 75, 150 minus by divided by 25 centimeters, 6 centimeters, minus 6 centimeters. Since we got it negative, what it means? So this is our principal axis. So we already know it will be formed at a 37.5 negative, that means in this direction. And what is the height of it? 6 centimeters. The original candle light is 4 centimeters, but this is from main axis. We have to go down because it is negative, and this is 6 centimeters. That's how we saw how to solve the problem. Hi, I see there is one other question that is in the exercises. So this is I just copied the question here. A convex mirror with a radius of curvature of 3 meters. So let me highlight all those numbers so that it will be easy. Okay. So 3 meters and used as a rear view mirror. So I'm not sure how many you know. So if this is your car, so here, okay, every car has okay, I'm not a best artist, so here there will be one mirror, here there will be, here I think this is a steering, so there will be 2 mirrors, one mirror here, one mirror here. So these are called side mirrors, not rear view mirror. So here next to the driving seat there will be one mirror. That is not to check your face, just kidding. So that to see the vehicles coming exactly coming on your back. So if there is a bus or something that is coming, so driver would see that from the rear view mirror that is next to the driver. That is called rear view mirror. But anyways, so I don't know whether this question is not to test your driving skills or anything. So he's just telling that mirror is kind of this kind of purpose. So that's what he is telling. And this is radius of curvature. And if a bus located at 5 meters from the mirror, find the position and nature of the and size of 3 things he is asking. Find the position, nature and size of the image. 3 things he is asking us. As I explained, this is our car and this is the rear view mirror, and it is of type convex. So you know how the convex looks like, right? So it is not straight. It may appear straight, but it is not straight. It is something like this. So the car, who is behind the car? Bus. There is a bus here. So the bus image is formed in this mirror. So the driver would sit here and check, oh, there's a car behind me. Okay, whether I have to give side or something, that's what the thing. So this entire bus image will be formed in this, on this lens, mirror. So he is asking what kind of image will be formed, etc. Position, nature and size of the image. So entire bus image can't fit in this one, right? It will be smaller in size. Let's see what's happening there. So all we know is one formula. What is that? 1 by F equal to 1 by U plus 1 by V. Universal formula. Okay. So what we have? As I explained, here he has given the radius of curvature, not the focal distance, please remember. So he has given a radius of curvature 3 meters. Okay, first of all, know this one. First we have to draw the diagram. That's one most important thing in physics or math. Since it is a convex mirror, this is our convex mirror, right? Okay, and the light is coming from, this is a bus. So this is our principal axis. And this is the bus. Think this is bus. And so bus is at a distance of what? This is our pole. And this is the focal. You see that circle is like this. When circle is like this, center will be here, focal point will be here, right? So on the concave, so circle will be formed like that. So center and focal points on the other side. Because this is a convex, so circle will be formed like this. Within the circle there will be a center and there is a focal line. So don't get confused. So P, and this is the object O. And when we see the distances, okay, let's see what it says. Radius of curvature is 3 meters. And what is our bus is located? This is the bus. So object could be bus, candle, anything. So here the object is bus, and which is at 5 meters. So from here to here is 5 meters. So object distance is what we denote? U. U is object distance. That is 5 meters. Please see, I am leaving a box here. So that would be plus or minus. Let's see whether it is a plus or a minus. So when R is 3 meters, focal length is half of it. So 3 by 2 meters. Box. Okay. Now let's decide the sign of convention. Object is here, so direction of the light is coming from this. So object to the mirror. This is how the light travels. That is positive. So going to the, you can take left or you can tell west or anything, or this direction is going from this direction. O to P is the positive direction, because that is how the light travels. That is positive. So we also know that we have to measure all the distances from the pole. Good. So I am here. So object, this is U. To measure U, how I have to travel? I have to walk like this. I am walking in the opposite direction of the light. So I have to take negative. So U is negative. Good, I got one sign. Next is focal length. So radius also both the signs same. Okay, let's figure out. So I have to measure distances from pole. So I am here. I have to move towards the center of the curvature. So this is my center of the curvature. So center of curvature is nothing but this is my curvature. If I make a big circle with that curvature, there will be a center. It will form a circle, and there will be a center for a circle, that is called center of the curvature. So how I have to walk? I have to walk in this direction. When I am walking in this direction, I am walking in the same direction of the light. Light is also going in this direction. I am walking in the same direction. So it is positive. So center of curvature is positive. And focal length. So this is my focal point. Even I have to walk from the pole to the focal point. I'll be walking there like this in this direction. So it's the same direction of light. So it is also positive. Now we got the signs. Let's do our 1 by f equal to 1 by u plus 1 by v. One by 3 by 2 plus 1 by u is equals minus 5 plus 1 by v, right? So here it will become 2 by 3. If you don't know how it becomes 2 by 3, so it is nothing but multiplying numerator with 2 by 3 and denominator with 2 by 3. This is another way of doing. 3 by 2, 2 by 3 equal to 1 by minus 5 plus 1 by v. 3, 3, 2, 2 cancels, it becomes 1, and the numerator is 1 into 2 by 3 is 2 by 3 divided by 1. So we can ignore this 1. Two by 3 equals minus 1 by 5 plus 1 by v. 1 by v equal to, I'm writing this one, 1 by 5 equal to 2 by 3. 1 by v equal to, I send this one on the other side, 2 by 3 plus 1 by 5, which is equal to 10, 13 by 15. Correct? I think so. V equal to 15 by 13. What is it? Meters or centimeters or anything? All calculations are in meters. So this is in meters. So we got a positive number. This is positive. What it means? I have to walk in the direction of the light. So I am at the pole. All distances are from the pole. So I go back to my pole and I have to walk in the direction of light. Direction of light is like this. So I have to walk in this direction. How much I have to walk? 15 by 13. That is approximately 1 point something. Right? Meters. So focal length is 1.5 meters. I have to walk 1 point, not 5. It will be 20 and 1.1 dash. So it will be, this is 1.5, means the image is formed at here. Right? So we got image position. This is our O dash, image position. So image position is here. And magnification. What is the magnification formula? M equal to minus V by U, right? So what is minus V? Minus V is 15 by 13 by U. U is minus 5 equal to minus minus cancel, 15, 13, 3 by 13. 3 by 13 is less than 1, right? You know that. So when it is less than 1, that means image is, if it is 1 means both height of the bus and height of the images are same. But here it is less than 1. That means it is smaller than the actual bus height. So whether we have to up or down, it is positive. So we always know that heights, if we go up, it will be positive. Up is positive, down is negative. Since it is positive, I have to go up. How much up? 3 by, to say, if it is 1, it will be 3 by 13. So let's take this as 1. So this is 3 by 13 means only this much, less than 1. So it will be smaller than the original one. If it is 1, both are equal. If it is less than 1, it's a smaller. If it is greater than 1, image is bigger than the actual one. Since it is less than 1, it is small. So we got all the points. Where is the position? Position is behind the mirror, here. So, and nature, it is erect. Erect means straight up. Size of the image, it is 3 by 13 and it is less than the original one. So position is, so one thing, okay, you observe, this is, I already applied clay or very strong material here. Can an image form behind that one? No, right? That's why it is called virtual image. It is virtual in nature. Virtual means imagine. There is no image, but you have to imagine image will be formed there. That's the intent. So position is, okay, this one, 15 by 13 meters, virtual and diminished image. Size is diminished. If height of the bus is not given, if the height of the bus is given, we could have got the exact height of the image. Since the height of the bus is not given, so we don't know the height. But one thing we can tell, it is, since it is less than 1, we can tell it is smaller. So smaller virtual image is formed at 1.5 meters from the pole. That's all about this problem. Thank you.